Hi folks, welcome to your very first set of notes for your Algebra 3 class. This is Mr. Lucas. Welcome to your class. I wanted to go ahead and just talk to you about taking notes in this class. Per the syllabus, there are 3 different ways you could take notes. Option 1, you could just jot them down on some notebook paper. That's what I did back in the day. I won't mention what year that was, but it is definitely an option. If you're going to just use a good old spiral-bound notebook to take notes, please know that I will be highlighting the things I expect you to have recorded in those notes. You will have more writing to do than a student who prints the note packet. You will have more writing to do than a student who downloads the note packet and uses the multitasking feature of the iPad to watch the video and take notes in a note-taking software of their choice. So if you're a notebook person, you will have more writing to do. It's still perfectly fine because, again, I survived it. My fingers are all here. See, look. But you will have more things to write down. Option 2, as I've kind of referenced, is for you to print the note packet and the pages and then just do them on paper, and you're going to upload those eventually. And then option 3 is, and I think if I had to pick, probably the best of the 3 options is just to watch that video on how to make your iPad multitask, download the packet into either Notability or Adobe, depending on what you're comfortable with and what you have access to. And then you're going to use that multitasking feature to take notes electronically and watch this video at the same time. That is, the more environmentally friendly of the options because you're not using any paper, and it also might save you some time. So it takes a minute to set it up. Well, probably more like 10 minutes to set it up. But once you get going on it, I think it's going to save you time and effort in the long run. That said, it is completely your choice. You are upperclassmen. You get to make those choices now. Just as long as you take some notes, we're going to be good. Notes are required. So I will be grading these in some way. That's going to come at you in a variety of different ways because I believe variety is the spice of life. And I'll talk a little bit more about how these notes are going to get graded as we carry on. All right, that was my bit about taking notes. So let's go ahead and get started. If you are a person who is taking notes on a piece of notebook paper, you're going to want to write the title down. We are in section P.1 of our chapter P Notes. And we are going to review real numbers and their properties. The objectives in this section are to classify your numbers as real, imaginary, etc., to really identify some common properties of algebra, and then to evaluate some algebraic expressions. We're going to practice the order of operations. What you're also going to notice is that you do have a warm-up at the top of pretty much every section. If you're working in notebook paper, you're going to want to take a minute to pause the video and jot down these problems in your warm-up. Your mission is to compare the 2 values in each problem. And when we say compare in math class, it sounds like a loaded word, but I'm just talking about less than, greater than, equal to, less than or equal to, or greater than or equal to. So you're not writing me sentences in that little circle. You're just putting some symbols in there. At this point in time, you go ahead and you pause that video, and we're going to go ahead and look at some answers. Alrighty there, folks. Did you get them right? Here's hoping. Go ahead and take a look and see how you did. I'm going to go ahead and pull that video in there. Whee! Oh, man, there's my big head. Okay. Number 1 is the less than symbol. 2 is greater than. 3 is less than. And keep an eye on those fractions. Remember, when your denominator is a big number, the value of the fraction is actually small. So 1/4 is indeed less than 1/3. That kind of flips on its head when we look at the negative end of the number line. Number 4 is greater than, 5 is greater than, 6 is less than, 7 is greater than, 8 is greater than, and 9 is less than. If you really struggled with that, I'm saying maybe missing more than 2, please go ahead and shoot me an email as soon as you are able, because we're going to need to iron that out for you super quick. We want you to get off to a good start. All right, this is going to seem boring, but let me rant on it for just a second. Yes, I want you to use page 9 in your text. Whoa, that's not a highlighter. Let me try that again. I want you to use page 9 in your text to fill out that chart. And you might be saying, oh, Mrs. Lucas, seriously, why are you having me copy stuff from my notebook?
Just a
And I will go ahead and let you know why that is. Many of you are heading off to some sort of post-secondary institution when you're done. And these college textbooks, they're expensive. The book that I gave you on the first day is roughly $120. And I'm here's hoping that when you go into your freshman year, you don't spend $120 on a book and never open it. So I need you to go ahead and practice using that math book. Reading a math book is actually a lot different than reading a social studies book. It's going to take you a longer bit of time. The issue here, in my experience at North Hills, is that math literacy is something that my students often need some work with. Reading a textbook is actually a different skill set. So it's my job to make sure you practice that skill set before, oh my goodness, I need to practice technology, before you go ahead and go on to college. So it's super important you get some practice pulling information from your math book and actually learning by reading the book. So this might look like a really, really boring exercise, but here's what I want you to do. Here's how it's going to benefit you. What I need you to do is, as you're copying the information from your book, I just want you to ask yourself one question. Do I understand what I am writing down? Your mission is to be able to pull in that information and even talk to, if we were in class, a friendly neighbor about it. So I would like you to go ahead and ask yourself that question as you're jotting some things down. If you don't have access to your book, let's say you're working right now and watching this video at work and you forgot your book, I get that very much. I'm going to go ahead and flip on over to the next slide, and a copy of the textbook is screenshotted there for you. So there is your properties on page 9 in your book. If you need to pause the video to jot those examples down, you can go ahead and do that now. All right, so let's practice using this particular skill. We're going to go ahead and take a few minutes to practice identifying the rules of algebra. So here, if you're taking notes in notebook paper, you're going to want to copy down example 1, part A, B, C, and D. And then you're also always going to record exactly what I have written. So I'm going to go ahead and do that for you. In part A, it does say, again, we're identifying the rule in the list of rules you just wrote down. We read that as the quantity of 5x cubed, quantity of 5x cubed times 2 equals 2 times the quantity of 5x cubed. Now, a lot of my students are going to see parentheses and they're going to be like, oh my gosh, it's the associative property. There's parentheses in it, but you got to be careful with what's in those parentheses. So when you look at this here, do you see how the 5x cubed is the same in both sets of parentheses? That can't be the associative property because nothing got reassociated. Remember, when you associate with things, you put them together. Well, nothing got associated here at all. There's no reassociating, so it can't be the associative property. When I look at this problem, what did change? Well, 5x cubed and the 2 just reversed. In other words, they kind of switched the commute. When they reversed the order in which they traveled, that's just your commute. So that's our commutative property. So this is the commutative property of multiplication. And I'll go ahead and let you know that when you go to take a quiz on these properties, there's a word bank. So you'll have the properties to choose from. All right, in part B, we have 4x. Oh, I'm sorry, I misspoke. It's the quantity of 4x plus 3 minus the quantity of 4x plus 3 equals 0. And what you need to know about this, anytime you see a 0 or a 1 in your property, you're using what I like to call the I properties. The I properties are your inverse properties and your identity properties. So we have 4 of them. We have the additive identity and we have the additive inverse. We have the multiplicative identity and we have the multiplicative inverse. So two inverse properties, and two identity properties. When you have the 0 or the 1, like here, when you have the 0 or the 1 by itself on one side of the equal sign, the things on the other side of the equal sign are undoing each other. That means they're inverses. Inverses is fancy talk in math class for opposites. So what we have on that other side are things undoing each other or being the opposite of each other to produce the 0 or the 1. So for that reason, part B is just our additive inverse. In part C, notice how that 1 is by itself on the one side. It's all by itself on that side of the equal sign. That's because if I have 7x and essentially divide that by 7x, I've undone that. So I have the multiplicative inverse. All right. Next up in part D. Oh, wait, let me back up for a second. You're probably saying, hey, Mrs. Lucas, there's 4 identity properties, or 4 I properties, 2 inverse properties, and then 2 identity properties. So you might be wondering what the identity properties then look like. And I'll go ahead and let you know that they look really similar to B and C. In other words, they're going to have a 0 or a 1 in them, but that 0 or 1 is not by itself on one side of the equal sign. So if you needed like a real quick example, for instance, if I did, I guess if we have A, B, C, D, I could call this part E as an extra example, E for extra, right? I could do 2x plus 0 equals 2x. Do you see how that 0 is sort of not by itself on the one side? And then I also, what I have on the left side just came right back out on the right side. I have the identical thing on the other side of the equal sign. That's how I remember it's the identity, because I have the identical thing on the other side. So that is your additive identity in part E. So I'd have the additive. That's an example of our additive identity. My stylus is not cooperating. And then that bubble is going to get in the way. Move, bubble. Okay. Thanks for hanging with me with the technology. Okay, part D. What you're going to notice, see how there's parentheses? Yeah, you can go ahead and get excited. It's cool. I know I do. What's in the parentheses did change. It's different than here. What was in the parentheses stayed the same. Here, the quantity that's in the parentheses is different. So what does that mean for us? That means we reassociated things. We regroup things. So that is going to be our associative property of addition, because I was adding. And again, I took some abbreviations. You can do some abbreviations in your assignments for tomorrow. But what I wanted to let you know is, with regard to your abbreviations on your quiz, no abbreviating. It's a text box, and you have to type the entire property in to actually get the problem right. So, little heads up, you will have a word bank, and you'll have to type in the entire property. Now you get to try a little bit of independent practice. You can go ahead and press pause right now and see if you can just take a real quick guess. Take 2 seconds, try it independently. See if you can go ahead and get these couple problems right. All right, let's see how you did. Get my big head out of the way. Whoa, let me delete everything on the slide. Just kidding. See if I can move myself around. There we go. Whee! I'll come up here. All right, so in part A, see how the X and the 9 switched? That's our commutative property of addition. B is the associative property of multiplication, because I reassociated things. Do you see how what's in the parentheses did change? So we reassociated things, we regrouped things, so that's our associative property of multiplication. And then for part C, they just distributed the y squared into that quantity, so that is our distributive property. Alrighty, kids, a little bit of vocabulary. You can either listen to me talk through it or press pause to jot these down in your notes. If you're a person taking notes on notebook paper, you're going to go ahead and jot all this down. So first thing we have is the substitution principle. It's on page 8 in your text. Basically, that principle states that if A is equal to B, then B can replace A in any expression involving A. Next vocabulary term is to evaluate, also on page 8 in your text. When we evaluate an expression, which is the second part of today's lesson, when we evaluate, that definition means to substitute numeric values into an algebraic expression and perform the indicated computations based on, your friend and mine, the order of operations. I won't make you write out the entire order of operations, but you should copy down that vocab term and at least the phrase PEMDAS. Some of you know it as please excuse my dear Aunt Sally. And you have 2 exceptions to it. 2 exceptions. Exception number 1, addition and subtraction get done in the order they appear. So do multiplication and division. And 2, you want to work out your computations that are in your numerator and then the denominator before actually dividing. So it's not like if you see subtraction before addition, according to the order of operations, you think add and subtract, but we actually do addition and subtraction in the order we see them. Same with multiplication and division. And with regard to a big fraction, you want to work out the little mini math problem on the top and then the little mini math problem on the bottom and then divide. Let's try it out. I'm not going to have you do problems just with straight order of operations because you're, I think, a couple notches just above that. We apply it by using that principle of substitution on the previous slide. So in part A, when I see negative 3x plus 5 when x equals 3, that means wherever I see an x, I'm allowed to replace it with a value of 3. So if I go ahead and do that, I have negative 3. I'm going to open up a blank where I see the x, and I'm going to put some parentheses there, and then I'm going to bring down that plus 5. Oh, by the way, if you're a person who's working on notebook paper, you want example 2, and you want these things copied into your paper notebook. Okay, back to actually doing the problem. You'll see that whenever I have an x, I always open up a set of parentheses, especially if I'm a person that leans on a calculator for some of my computations. Failure to open up these sets of parentheses for a person who uses a calculator is going to result in incorrect responses. So please make sure that if you're a person who leans on a calculator, hey, I'm not judging. Nope, not at all. You just need to make sure that your calculator doesn't lie to you. You're going to need to make sure that you open up that set of parentheses in your calculator too. So with that, let's do it. I have negative 3. I'm going to grab a different color here, sorry. And the x value that they mention here is x is supposed to be 3. So I have negative 3 times 3 plus 5. I'd also like to practice using the order of operations because that's sort of one of our goals. We're going to go ahead and multiply before we add. So in this problem, negative 3 times 3, that product is negative 9. Add 5, you get negative 4. What's interesting, we are going to graph here in a couple of days, which is also the part of the end game of this. You could write this answer as an ordered pair. So in other words, when I plugged in 3, I got negative 4 back out. So that would be a point on this particular relation that I could then graph. All right, let's try it out with part B. And if you're a calculator user, especially on this one, you want to open up that set of parentheses. So here's how that's going to look. We're going to do 3 times the quantity of blank squared plus 2 times blank minus 1. And then I'm going to go ahead and plug that value of negative 1 into that blank. When you square a value of negative 1, that is the same as taking negative 1 times negative 1. You might be asking, why are you squaring the negative 1 first? And it's because exponents come first in this particular problem according to our order of operations. So I have to go ahead and take care of that right there. So the 3 is going to come along for the ride. And then, like I said, -1 times -1 is actually a product of +1. If you go ahead, take a hot second right now to plug that into your calculator without the parentheses, if you just did -1 squared in your calculator, you'd get -1, which isn't the same as 1. Therein lies the error. So when you square all of -1, that product is +1. It's one of the most common mistakes in all of algebra. So if you're a person who's fallen for it in the past, you should know that you're definitely not alone. It is one of the top 3 algebraic errors made in all of mankind's history. Fun fact. Okay, so I'm going to go ahead and bring down the rest of my problem here. In this line now, I'm supposed to multiply before I add and subtract. So the product of 3 and 1 is 3. Bring down my plus. The product of 2 and -1 is -2. And then I can bring down my -1. Addition and subtraction just get done in the order that you see them. So 3 plus a -2 is 1 minus 1. We get 0 for our answer there. All right, last one. We got 2x over x plus 1 when x equals -3. So again, I always copy down the expression, putting blanks where the x is. And then I'm going to go ahead and throw -3 in for x using my principle of substitution. So what I get here, I got to work out the little mini math problem on the top and then the little mini math problem on the bottom. That's one of my exceptions to the order of operations. So 2 times -3 is -6. -3 and 1 is -2. And then the quotient of -6 and -2 is +3. Okay. Once again, you could write these answers, if you wanted to, as ordered pairs. Coordinates, things you could plot on a graph. Again, part of our end game here. So in this problem, when I plugged in -3 in, I got 3 back out. And then here, when I plugged in -1, I got 0 back out. Ooh, I got an intercept. That's exciting. We'll talk about that a little later. Preview of coming attractions. Okay. A little bit of independent practice for you. This is the point where you pause. And you go ahead and give it a whirl. See how you did. All right, let's check it. How'd you do? We're going to run through it. Normally when I teach this lesson in front of humans, I see some mistakes happening, particularly on G. So I was going to go ahead and go over that. But in our Zoom sessions, you are always going to be asked about the previous day's lesson. So we'll talk about this video and these problems to kick off our Zoom tomorrow. So what I wanted to let you know is that here in part G, again, you got to square all of -4. So watch that and make sure you have a +16 in those parentheses. That's going to be the common error that I see. So when you square -4, that's +16. And then evaluating, you multiply before you subtract, you should get 31. That's usually the most common one missed, but if you missed another one and you want to ask about it, by all means, you could screenshot it, send it to me via email. You could ask about it in our Zoom. Totally your call. All right, and then these we will talk about tomorrow during our Zoom, our conclusion questions. The short answer to both A and B is no. Subtraction is not commutative, and B, division is not commutative. And we're going to go ahead and talk about examples as to why that is. I hope you found this. And we will